In the dark, pivotal winter of 1940, the shadow of Nazism stretched across a defeated Europe, and the free world seemed to shrink by the day. Britain, isolated and battered by the Blitz, fought its war of survival on a razor's edge. This was the moment President Franklin D. Roosevelt chose to speak to a deeply anxious nation, sitting by his fireside microphone. The atmosphere was thick with dread, yet Roosevelt met it with an unprecedented, unwavering declaration. America must become the arsenal of democracy. The physical challenge he laid out, the production of a seemingly unthinkable number of warplanes, 50,000 airplanes a year, was a direct, industrial response to global fear. This figure was not just ambitious, it was a profound break with precedent, representing a 25 times increase over the entire American aviation output of 1939. Achieving Roosevelt's objective required more than simple expansion. It demanded a fundamental, systemic transformation of manufacturing. It became immediately clear that this astronomical goal could only be met by leveraging the ruthless efficiency, vast scale, and uncompromising assembly methodology of Detroit's automotive giants. The urgency was palpable. If they failed, the last beacon of liberty would fall dark. It is essential to note that this effort, while uniquely American in scale, built upon the already enormous and sustained industrial efforts underway in Great Britain and the Commonwealth. The cornerstone of this required aerial armada was the long-range heavy bomber. While the Boeing B-17 Flying Fortress earned legendary status for its rugged durability, the War Department ultimately selected the consolidated B-24 Liberator for its primary mass production program. The decision was rooted in practical industrial strategy. The B-24 offered superior range and a larger internal bomb load, but critically for mass production, its simple slab-sided design was inherently more adaptable to being broken down and fabricated via repetitive, high-volume techniques than the B-17's complex curved structure. The Liberator, regardless of its suitability for standardization, remained an engineering leviathan. It possessed a 110-foot wingspan, weighed over 18 tons when empty, and was constructed from over 1.5 million individual components. The B-24's design employed a semi-monocoque shell, a stressed skin structure where the outer aluminium skin bore much of the flight load, which required absolute precision. Traditional aircraft fabrication was a painstaking, slow craft, relying on skilled workers to custom-fit pieces, yielding perhaps one bomber per month. To deliver the thousands required to win the war, this intricate product had to be completely redefined, recast as a simple, repeatable, uniform commodity, ready for mass production. Its only major operational drawback was its vulnerability to battle damage compared to the B-17, particularly in its volatile, fuel-filled, high-aspect Davis wings. This vulnerability had to be accepted in exchange for overwhelming quantity. When the challenge reached Detroit, the initial reaction from the auto engineers was a turbulent mix of skepticism, aggressive excitement, and outright fear. 50,000 planes. It felt like science fiction. While the Detroit establishment was initially hesitant, the mission was ultimately entrusted to the Ford Motor Company. The determined force behind the transformation was Charles Sorensen, Ford's production chief, widely known as Cast Iron Charlie. Sorensen's expertise was the absolute mastery of the moving assembly line, the process that had defined modern industry. When Sorensen toured existing aircraft sites, he was dismissive, finding their operations technologically medieval, scattered parts, manual tooling, and a complete absence of synchronized flow. He famously declared they were building handcrafted prototypes, not preparing for a global conflict. His counter-proposal was unprecedented. Ford would erect an entirely new factory on 1,400 acres of flat, open farmland near Ypsilanti, Michigan. This site, designated Willow Run, would be the single-purpose structure to house his vision. The manufacturing logic would be inverted. The B-24 would be meticulously separated into thousands of interchangeable parts, manufactured in synchronized parallel departments, and delivered precisely to one massive, mile-long conveyor belt system. Sorensen's audacious vow, which stunned military officials, was to deliver a complete liberator every single hour. The Nazi leadership's response to America's colossal pledge was rooted in a fatal ideological disdain for the American system. When Roosevelt announced the 50,000 plane target, Reichsmarschall Hermann Göring, chief of the Luftwaffe, was widely attributed as laughing derisively and branding it pure propaganda, dismissing the figure as preposterous American boasting. This scorn stemmed directly from the German focus on the Meister, master craftsman tradition. They prioritized the qualitative superiority of complex, bespoke engineered weaponry, believing that only an elite, highly skilled, and racially homogeneous labor force could produce frontline instruments. They viewed the incoming wave of American workers, a diverse mix of women, recent migrants, and African Americans, as undisciplined, unskilled, and utterly incapable of the required technical precision. Consequently, as intelligence reports confirming the colossal size of Willow Run and its hourly output goal reached Berlin, they were routinely rejected as Allied disinformation. The idea that a single, newly constructed facility, built on a former farm, could soon eclipse the entire German aerospace industry was considered numerically impossible. This blindness to the power of standardization and overwhelming scale was the most critical non-military miscalculation of the war. They were prepared for a war of craftsmanship. America was prepared for an unstoppable war of arithmetic. With Sorensen's architectural blueprint approved and the industrial strategy fixed, the magnitude of the task became clear. The next challenge would be to physically manifest this vision, pitting American ambition against the constraints of wartime materials and the staggering limits of industrial design. The design of this industrial titan fell to Albert Kahn, the era's preeminent industrial architect. Construction on Willow Run began rapidly in 1941, expedited by vast government subsidies and priority allocation of materials. The early months of construction were a scene of massive frantic chaos. The incessant clang of steel beams, the deafening thump of pile drivers, and the odour of fresh asphalt over turned-up farmland. The final structure spanned a colossal 3.5 million square feet, approximately 80 acres, making it the largest single industrial building in the world at the time. Kahn's design was a functional masterpiece, prioritizing linear flow and a decent working environment. To combat the pervasive gloom typical of older multi-story factories, Kahn incorporated vast monitor roofs, north-facing skylights designed to flood the floor with cool, consistent natural light, thereby reducing eye strain, minimizing electrical consumption, and reducing assembly errors. The building also featured enormous advanced forced air ventilation systems designed to exchange the factory's entire air volume multiple times per hour. The strategic L shape allowed the mile-long conveyor system to achieve its full length, culminating in the engine run-up area where Finnish bombers would roll directly onto the adjacent airbase for mandatory test flights. A perfect continuous cycle from raw material to combat asset. The sheer logistical feat of acquiring and fabricating the necessary 100,000 tons of structural steel during severe wartime shortages was a testament to the project's absolute priority. This aggressive pursuit of raw materials, particularly aluminium for the aircraft itself, came with an immense environmental toll, requiring the rapid and costly expansion of mining and smelting operations across the nation. The technical feasibility of the entire project hinged on the successful transformation of the B-24 from a hand-built airframe into a sequence of interchangeable components. The original consolidated plans were virtually useless for Ford's mass production model. Ford's engineers were tasked with creating a completely new set of plans, an unprecedented technical effort requiring over 10,000 new blueprints and the establishment of microscopic tolerances for every joint and part. They structurally dismantled the B-24's complexity, dividing the massive bomber into 69 major sub-assemblies. These components, the wing sections, the tail units, the various fuselage sections, were fabricated in separate parallel departments before being precision-fed into the final flow. This process was the unseen engineering war. To guarantee interchangeability, engineers devised elaborate jig designs and tooling systems that ensured, for example, that every single rivet hole on every wing spar was identical to its counterpart, typically within a tolerance of 0.001 inches. This meticulous dedication to component uniformity meant that any part, regardless of whether it was built at Willow Run or by a distant subcontractor, could be snapped into place without time-consuming manual refitting. This level of standardization was the crucial intellectual victory that validated the potential of the automotive approach. Despite the meticulous planning, the initial ramp-up was agonizing. The year 1942 was marked by managerial chaos and logistical friction. This was the dark before the dawn. The assembly line, meant to be a swift river of aircraft, was instead a clogged, stagnant swamp. Half-assembled bombers sat stranded on the floor, the metallic scent of fresh aluminium mixing with the bitter odor of burnt-out machine oil and human frustration. The chaos was visible. Parts were mislabeled, tools were missing, and the colossal main line was continuously paralyzed by severe subcontractor issues whose components failed to meet the tight Ford tolerances. Compounding the crisis were continuous military design changes and a cripplingly high rate of labor turnover that often exceeded 1,000 workers a week. New staff struggled to adapt to the rigorous precision demanded by aircraft work. One foreman, interviewed later, recalled the stress of watching a $300,000 bomber stand idle for 3 days because a single, mismatched wing bolt wouldn't fit. Managers barked orders into the din, while reporters gathered outside whispering about failure and derisively dubbing the struggling factory, "Will it run?" By the close of 1942, the plant had produced only 56 complete Liberators, a rate so dismal it triggered a formal congressional inquiry. Willow Run risked becoming an expensive public symbol of American overreach. The crisis demanded singular, uncompromising leadership. Edsel Ford, despite his own rapidly deteriorating health, took decisive personal operational control. He ruthlessly streamlined the convoluted management structure, eliminating the paralyzing bureaucratic friction between Ford executives, consolidated engineers, and military oversight committees. Edsel's most critical action was the enforcement of an absolute priority on the bomber schedule above all other concerns. Supported by Charles Sorensen, the leadership team focused obsessively on stabilizing the component supply chain and perfecting the tooling flow. They ruthlessly replaced faulty managers and instituted strict quality control checks at every stage. By late 1943, the foundational work, the perfected blueprints, the stabilized part supply, and the fully trained staff finally synchronized. The bottlenecks were systematically cleared, and the long, powerful momentum of the unified production line began its relentless acceleration, preparing for the crushing rate of output that would soon define the plant. With the technical and managerial barriers neutralized, Willow Run became an unprecedented magnet for labor. The next transformation would be profoundly social, as thousands of Americans descended upon Ypsilanti, changing the face of the industrial heartland forever. Willow Run's insatiable demand for manpower, a workforce that eventually swelled past 42,000 people, fueled one of the most massive internal population shifts in American history. Workers poured into Michigan, primarily from the rural South and Appalachia, drawn by patriotic duty and the promise of high wartime wages. The instant population boom created a logistical nightmare. The air was thick with the intense scent of welding smoke mingled with the clamour of sheet metal and the distant whine of electrical transformers. The sudden, enormous influx created an immediate and profound strain on local infrastructure. Housing was instantly saturated, leading to massive social instability. Workers often lived in desperate temporary conditions, in tents, converted garages, or overcrowded boarding houses, paying exorbitant rents for minimal space. The government responded with urgency, authorizing the construction of the Willow Run village, a large, federally subsidized community designed to house thousands of families. This instant city became a diverse, fragile, and often conflicted social experiment, forcing strangers from wildly different backgrounds into immediate close proximity. The war's unquenchable need for labor permanently dissolved deep-seated pre-war labor barriers. At its peak, nearly 40% of the Willow Run workforce, over 12,000 individuals, were women. These workers, who became the face of the Rosie the Riveter campaign, excelled in roles previously restricted to men, operating massive presses, milling machines, and performing the high-precision assembly work required for aircraft. For many, it was the first taste of economic independence. The plant was a major stronghold of the powerful Congress of Industrial Organizations Union. The Congress of Industrial Organizations was instrumental in enforcing a strict policy of equal pay for equal work, ensuring that women and minority employees received the same competitive hourly wages as their white male counterparts. This economic parity was a revolutionary step, validating the principle that skill was transferable, and that output, not gender or social status, was the only metric that mattered on the factory floor. Despite wage equality, the social landscape of Willow Run was a flashpoint for severe racial tension. Ford hired thousands of African American workers who migrated north from Jim Crow states, drawn by unprecedented industrial opportunity. This workplace integration, however, clashed violently with the rigid housing segregation and racial prejudice in the surrounding metro area. The daily soundscape of the plant was a strange mix of precision and chaos, the staccato whirring of thousands of rivet guns punctuated by the thud of hydraulic presses, all driven by human will. This intense, shared environment sometimes bred unity, but outside the gates, tension mounted. It exploded dramatically in June 1943, when the catastrophic Detroit race riot erupted, killing 34 people. The violence had immediate and devastating effects on Willow Run's operations. Black workers, fearing for their lives, struggled or refused to commute, and absenteeism among the crucial black labor pool spiked, threatening to cripple the entire production schedule just as it was starting to gain momentum. The factory floor, under the intense pressure of the war schedule, became an emergency model of enforced integration. Management was forced to collaborate directly with Congress of Industrial Organization leaders, particularly the influential Walter Reuther, who mediated labor disputes and helped organize guarded transport for workers through hostile territory to maintain continuity. Oral histories from the time highlight this duality. A black worker might speak of the fear of passing through certain neighborhoods to reach his shift, contrasting sharply with the sense of equality felt when operating a heavy machine. Meanwhile, a woman from rural Kentucky recalled the intimidating size of her first rivet gun, only to find the rhythm of the work therapeutic and the paycheck liberating. With the workforce disciplined, unified, and operating at peak capacity, the plant achieved its industrial maturity. The theoretical numbers were about to become a devastating reality, sending a shockwave that the Axis command could no longer ignore. The German belief in industrial superiority was rooted in a foundational commitment to precision craftsmanship and technical complexity. They clung to the notion that the qualitative advantage of a complex, bespoke engineered machine would inherently defeat any simple numerical advantage held by the Allies. In a smoky Berlin office, a Luftwaffe analyst might have scoffed at a report detailing Willow Run's initial production failures. The notion that unskilled Americans could build a bomber in an hour, while German meisters took weeks, was deemed propaganda or evidence of sloppy, unusable construction. This was their fatal conceptual flaw. The Allies' aim was not to build the best single bomber. It was to build an overwhelming number of a good enough bomber. The relentless flow of Liberators from Willow Run meant that Allied bomber losses were instantaneously replaceable. German fighter and tank losses were permanent, irreversible drains on their manpower and resources. Albert Speer, Hitler's Minister of Armaments and War Production, was one of the few high-ranking Nazis to grasp the inevitability of industrial defeat. Speer, an intelligent organizer, managed to achieve a significant, but ultimately futile, surge in German fighter production in 1944 through streamlining and standardization programs. However, Speer also received the intelligence reports detailing the actual scope of Allied production. He later confessed that upon seeing the figures, the US alone built nearly 100,000 aircraft in 1944. He realized the war was irrevocably lost. Imagine Speer in his bunker, silently absorbing the raw data, the single factory output of Willow Run, which sustained a production rate of over 400 bombers per month, proved that the Allied capacity was boundless. This sheer repetitive volume of production, backed by an unyielding supply chain, negated every tactical success the Luftwaffe might achieve. This was the inevitable arithmetic of defeat. Willow Run represented the epitome of streamlined, centralized flow. The entire process, from raw aluminium sheets to final flight tests, was integrated within one linear, massive structure, eliminating external logistics and maximizing synchronous movement. In direct contrast, the German industrial structure was characterized by chaotic fragmentation. Under the constant punishing bombardment of Allied strategic bombing, German airframe and component production was deliberately dispersed into a labyrinthine network of small scattered facilities, including fortified bunkers and vast underground factories like the notorious Mittelwerk. While this decentralization offered temporary bomb protection, it created crippling logistical breakdowns. Supply chains for specialized components became fragile, and the strict quality control required for interchangeable components was impossible to maintain across dozens of separate sites. Furthermore, these decentralized facilities, especially Mittelwerk, relied heavily on forced labor, prisoners of war and concentration camp inmates, an ethical failure that also proved to be a practical industrial failure. Slave labor was inherently inefficient, untrained, prone to disease, and actively engaged in sabotage and shoddy workmanship to undermine production. The result was a high rate of defective products. The contrast was stark. Willow Run's single unified factory achieved a peak rate of 428 Liberators in a single month. The entire German aviation industry, which was highly fragmented, managed a total output of only 39,807 aircraft for the entire year of 1944. The American strategy of massive focused scale, supported by a paid and motivated workforce, proved fundamentally superior to the German strategy of dispersed, unethical defense. This fragmentation, driven by their desperate attempt to escape Allied aerial supremacy, simply created more targets for the strategic bombing campaigns, making the German system increasingly brittle with every passing month. As the floodgates opened, the Axis could no longer deny the inevitable arithmetic of defeat. The final chapter of the war would be written by the unyielding velocity of American-made steel. By the spring of 1944, the cumulative effect of engineering perfection, management reform, and mass training finally paid off. The massive, mile-long conveyor belt system achieved a velocity previously thought possible only for simpler industrial products. The relentless roar of the four Pratt & Whitney R1830 twin-wasp radial engines being run up in the final bays, coupled with the rhythmic clatter of the conveyor belt, created an oral testament to industrial power. The line's efficiency became absolute, enforced by the rule that an issue in any section immediately halted the entire flow, demanding intense cooperation and synchronization from every single worker. The result was the fulfillment of Sorensen's impossible prophecy. The average production time for a finished B-24 plummeted from an initial 125,000 man-hours to just 6,500 man-hours. A complete flight-ready B-24 Liberator rolled off the line every 63 minutes, sustained 24 hours a day, 7 days a week. The factory's output alone became a strategic, tide-turning force, proving that the American concept of uninterrupted industrial flow was the most potent weapon of the war. When the war production contract ended in May 1945, the final accounting confirmed Willow Run's legendary status as the most productive factory in history. The plant manufactured a grand total of 8,685 B-24 Liberators. This immense single-source output ensured that the B-24 Liberator became the most produced multi-engine American military aircraft in history, with over 18,000 total units constructed across all sites. Furthermore, the sheer scale of the operation required a massive workforce, which stabilized at a peak of over 42,000 individuals. The sheer volume of B-24s provided by Willow Run made the Liberator indispensable across every global operation. Its long range and high payload were critical for strategic bombing runs deep into Axis territory. In the European theatre, Liberators flew in massive formations against German oil refineries and industrial hubs. They were central to the highly dangerous low-altitude Ploiești oil raids in Romania in August 1943. 178 B-24s participated in that single costly mission, with 57 aircraft lost. Yet the continuous replacement flow from Willow Run absorbed these immense losses, ensuring the mission could be repeated and sustained, ultimately cutting German fuel production by over 30% and crippling their mobility. In the crucial Battle of the Atlantic, the very long-range PB-4Y1 Liberators were the decisive factor. Flying vast, monotonous patrols, these aircraft finally closed the final gap in anti-submarine air coverage, the Black Gap. The B-24's presence reduced German U-boat effectiveness in the Atlantic by over 75% by mid-1943, leading to the sinking of dozens of U-boats and safeguarding the vital supply convoys that were essential for the invasion of Europe. The constant, relentless stream of replacement aircraft from Willow Run ensured that every loss at sea or over Europe was immediately countered by a fresh Liberator rolling out of Michigan. The B-24's global reach was defined not just by the Atlantic and Europe, but by the vast, unforgiving expanses of the Pacific theatre. While the B-29 Superfortress captured the spotlight for raids on the Japanese homeland, the Liberator was the true workhorse of the early and middle Pacific campaigns, often flying out of extreme distances from remote, hastily built airbases. In the China-Burma-India theatre, B-24s faced the dual challenge of flying over the towering Himalayan hump and operating without adequate logistical support, supplying forces and hitting Japanese supply lines deep within Burma. It is also important to note the critical support provided by the Royal Air Force and Commonwealth forces throughout the Burma campaign, with Royal Air Force Liberators playing a vital maritime patrol and transport role in the theatre. Their range was critical for hitting targets like Japanese oil fields and supply depots in Southeast Asia. The Liberators' ability to carry substantial bomb loads over such vast, hostile distances meant it was essential for the slow, painful process of island hopping, providing crucial ground support and neutralizing forward air bases well ahead of Marine and Army landings. Perhaps the most grueling operations took place against the oil refineries on Borneo. In 1944, B-24s mounted the epic long-range raids against the Balikpapan oil complex in Dutch Borneo, considered the most heavily defended Japanese oil source outside the home islands. These missions required flights of over 3,000 miles round-trip, crossing enemy-held jungle and ocean. Losses were frequently severe. For example, the raid of October 1944 saw significant aircraft downed, but the relentless flow of fresh Liberators from Willow Run ensured that the pressure was sustained. The B-24 provided the indispensable, continuous aerial presence that gradually strangled Japan's access to vital resources, turning the tide of attrition in the Pacific. The Willow Run bomber plant, though its primary mission ended in May 1945, left an indelible mark on the American industrial landscape. The end was as dramatic as the beginning. On the day the last B-24 rolled off the line, the vast, mile-long final assembly line fell silent for the first time in years. Workers watched in silence as the roar of the engines faded, replaced only by the echo of their footsteps and the sudden, profound quiet of the immense space. The ceaseless, rhythmic thud of the assembly line was gone. Ford chose not to purchase the facility, but its life continued under new management. The factory was immediately bought by Kaiser Frazer, which adapted the immense space to produce passenger cars, manufacturing over 739,000 vehicles between 1947 and 1953, linking Willow Run directly to the post-war automotive boom. Subsequently, it was taken over by General Motors for automotive and transmission production, anchoring the post-war industrial strength of the Detroit area for decades. Methodologically, the success of Willow Run validated the principles of total industrial mobilization for complex products, setting the template for future Cold War aerospace contracts. The direct descendants of Willow Run's techniques, focusing on subassembly synchronization, interchangeable components, and continuous linear flow, can be seen in modern manufacturing, from the high-rate assembly processes of the Boeing 737 to contemporary electric vehicle gigafactories. The legacy of Willow Run endures, a monument to the power of American scale and a stark reminder that in the face of tyranny, industrial capacity itself can be the most potent weapon, driven by the synchronized effort of a determined and united workforce.